Hi student friends, welcome to AS Engineering Academy. Right now we are going to discuss the solutions for 2022 GATE CSE paper, especially for computer organization and architecture subject. COA, computer organization and architecture. This is Y.V. Ramaya. I think most of the students know the same. Especially in 2022 GATE paper, our subject, COA subject, has occupied 3 number of 1 mark questions and 3 number of 2 marks question. Along with these 6 questions, 2 more questions are there. Those are linked to other subjects. First, let me complete the analysis and clear explanation for these questions. Let us start. Observe this question. First, read the question carefully. Try to understand the question, what he gave and what he asked. Which one of the following facilitates transfer of bulk data from hard disk to main memory with the highest throughput? It is multiple choice question, MCQ, multiple choice question. And at the same time, simple question it is. I am going to read the question once again. Which one of the following facilitates transfer of bulk data from hard disk to main memory with the highest throughput? First, let me explain throughput. Generally, throughput means number of operations to be completed within 1 second time. In this, what about the meaning of throughput here? Number of bytes to be transferred in 1 second time. In this, he asked the highest throughput means simply fastest data transfer. What about first one? DMA based IO. Second one, interrupt driven IO. Third one, polling based IO. Fourth one, programmed IO transfer. It is related to secondary memories IO organization question. While transferring the data from secondary memory to main memory, generally DMA method is used. Here, hard disk belongs to secondary memory. There are 3 data transfer techniques. First one is programmed IO. Second one is interrupt-driven IO. Third one is DMA IO. In programmed IO transfer, one lengthy program is needed to execute for transferring only 1 byte of data. That's why it is the slowest method. Slowest method. Next, what about interrupt-driven IO transfer? It is faster than programmed IO, but for one interrupt request, it can transfer only 1 byte. So, it performs only average speed. At the same time, it is used to save the valuable time of the processor. What about the merit of this interrupt-driven IO transfer? It is used to save the valuable time of the processor, means no time waste will be there. Next, what about polling based IO transfer? It belongs to the one of the techniques in interrupt priority method. DMA based IO, it is the correct answer. Correct answer is A only. In DMA based IO, there are 3 methods to transfer the data. First one is burst mode. In DMA, there are 3 methods. What about first one? Burst mode, also known as continuous DMA. Second one, cycle stealing. Third one, interleaved DMA. Interleaved DMA. In this, burst mode is used to transfer the bulk size of data from secondary memory to main memory. Here, merit of the burst mode is to transfer the data from secondary memory to main memory without involving CPU at fastest rate. While transferring larger size of data, generally this method is used. In cycle stealing method, at a time, only 1 byte will be transferred. So, cycle stealing method is preferred while transferring the data size, when the data size is maximum 10 bytes. Interleaved DMA. In this method, both DMA controller and processor share the bus services in alternative clock cycles. Means interleaved DMA provides moderate speed, cycle stealing provides least speed, burst mode provides highest speed. So correct answer is DMA based IO. In this also, which method it uses for transferring highest throughput? Burst mode. So correct option is A. Observe this question. Consider three floating point numbers A, B and C stored in registers RA, RB and RC respectively as per IEEE 754 single precision floating point format. First get 100% clarity in question. The 32-bit content stored in these registers in hexadecimal form are shown below. Means each register size is 32-bit. Here, before data he mentioned 0x means the data belongs to hexadecimal. RA, RB, RC, register contents are given. Which one of the following is false? He asked the false one in these four options. Which one of the following is false? That's why it is MCQ question. Multiple choice question. Okay. For solving the same, first you find the decimal value for the register contents. First you remember one thing, these registers size, all registers size is 32-bit and expressed in IEEE single precision means 32-bit notation. In this, it is also known as IEEE 754 standard. First of all, what is RA content here? RA is nothing but C. Convert hexadecimal to binary. While converting hexadecimal to binary, each hexadecimal digit requires 4 bits. C means 1100. 1 means 0001. Next, 4 means 0100. Remaining all are zeros. Size of the each data is 32-bit. In this, MSB is reserved for sign. Remaining next 8 bits are used for biased exponent 1, 2, 3, 4, 5, 6, 7, 8. It is nothing but biased exponent. Sometimes we use capital E also. Next, it is nothing but mantissa. Expression value for finding the decimal equivalent is nothing but value expression. Also known as expression value is nothing but -1 whole power s into -1 whole power s. Here s is nothing but sign bit into 1.m. Here 1 is nothing but a hidden bit into 2 power biased exponent value -127 because here biasing value is nothing but 127. Find the biased exponent value in decimal. Here biased exponent value in decimal is nothing but here 1 0 0 0 0 0 1 0. It is binary value. For finding the decimal value, apply weighted code 1, 2, 4, 8 like this. Means 2 power 0, 2 power 1, 2 square like this. 1, 2, 4, 8, 16, 32, 64, 128 means 130. Here, biasing value is 127. Biased exponent value is 130. Then true exponent, small e is nothing but true exponent. Nothing but biased exponent value minus biasing value means 3. Since BE is nothing but B plus E, what is small b here? Biasing value nothing but 127. What about small e here? Small e is nothing but a true exponent. Small b is nothing but biasing value. Now in this, find the decimal value for the same. In this, decimal value for the same is like this. For which one? For RA. Here minus 1 whole power. What is S here? S is nothing but 1 into minus 1 whole power 1 is nothing but minus 1 into 1 point. Mantua value is nothing but 1 0 0 0 like this. Into 2 power. This value is nothing but 3. Here Mantua size is 23 bit. At the same time biased exponent size is 8 bit. This size is 1 bit. Total 32 bit. Now in this, if you convert 3 to 0 in place of exponent, then directly this binary value provides the decimal value. Here it is nothing but minus 1100 into 2 power 0. It can be written like this. Have to shift the decimal point to right. For how many positions? 3 positions to get the 0 in place of exponent. Now it is nothing but 1, 2, 4, 8, nothing but minus 12. So RA value is nothing but minus 12. In decimal, RA value is nothing but minus 12. Next, what about RB value here? Observe this. It is RA value, it is RB value, and it is RC value. If you identify the difference between RA and RC, only first digit is differ. Except that one, there is no one more difference. That's why better to find the RC value. RC value first. 414. Remaining all are zeros. Here 4 means I am going to write the binary value for the same. 4 means 0100, 0001, again 0100. Remaining all are zeros. In these, it is nothing but sign. 1, 2, 3, 4, 5, 6, 7, 8, nothing but biased exponent. Here it is nothing but Mantua. If you observe Mantua and biased exponent, for RA and RC, both are same. Both are same. Watch carefully. Means biased exponent value is 127. Mantua value is same. Now at the same time, S is equal to 0 here, but here S is equal to 1. Means what about value expression? Value expression is nothing but minus 1 whole power. S means here 0 into 1 point. What is M value here? 1000 into 2 power 3. Means it is this one and this one are same except sign symbol. So minus 1 whole power 0 is nothing but 1. Nothing but plus 12. So what about RC value here? Plus 12. RA value minus 12. Next, find the RB value. What is RB here? 4 2 1 5 zeros. 4 2 1 5 zeros. RB is equal to 4 2 1 5 zeros. Here 4 means 0 1 0 0, 2 means 0 0 1 0, 1 means 0 0 0 1, remaining all are zeros. Now in this, here sign 1 2 3 4 5 6 7 8. It is nothing but biased exponent. It is nothing but Mantua. Here biased exponent value is nothing but 1 0 0 0 0 1 0 0. Means 1 2 4 8 16 32 64 128. Means nothing but 132. Already we know biasing value is 127. So true exponent value is nothing but 5 plus 5. Okay. Next, M value is like this. Since S is 0, sign symbol is positive. So Here value expression is like this: minus 1 whole power s into 1.m into 2 power capital E minus capital E or EB biased exponent minus 127 BE or EB exponent biased or biased exponent. It is nothing but minus 1 whole power 0 is nothing but plus positive, default sign is positive, not needed, right? Plus 1 point. What is m here? 0, 0, 1. This one is nothing but hidden bit. 0, 0, 1, remaining all are zeros. Length of the mantis is 23 bit into 2 power. Already we know true exponent 5. Okay. Now, to get 0 in place of 5, shift the decimal point to right. For 5-bit position, nothing but 1, 0, 0, 1, 0, 0 point 2 power 0. Not needed to consider this. Now, decimal value for the same is 1, 2, 4, 8, 16, 32. Nothing but 36. So, what about RA here? RA value is nothing but minus 12. RB value is nothing but 36. It is nothing but RB value. RC value is nothing but plus 12. Okay. Come to question once. Here, RA minus 12, RC plus 12. What is RB here? RB is nothing but 36. Now, what about option A? A plus C is equal to 0. What is RA value? Minus 12, C value plus 12. A plus C minus 12 plus 12 0. So it is true. He asked the false statement. It is true. T, true. Next. What about B? C is equal to A plus B. C is equal to A plus B. C value is nothing but plus 12. A plus B 36 plus minus 12, nothing but 24. So it is false. It is false. Option B is false. C, option C. B is equal to 3 into C. C value is equal to 12. 3 into C, 12 3 is 36. So B is equal to 3 into C. Yes, it is also true. What about D option? B minus C is greater than 0. B minus C. B value 36, C value 12. 24 is greater than 0. Yes, it is also true. So he also, since he asked the false statement, correct option is B only. Very good question it is. Watch this question. A cache memory that has a hit rate of 0.8 has an access latency 10 nanoseconds and miss penalty 100 nanoseconds. An optimization is done on the cache to reduce the miss rate. Optimization has been done. However, the optimization results in an increase of cache access latency to 15 nanosecond, whereas the miss penalty is not affected. The minimum hit rate, he asked for the minimum hit rate rounded off to 2 decimal places needed after the optimization such that it should not increase the average memory access time. First, get 100% clarity in the question. A cache memory that has a hit rate of 0.8 nanosecond. 0.8. Hit rate is 0.8. There is no unit for hit rate. It is NEAT question, numerical answer type question. Now, for this old cache, what about hit rate he gave? 0.8 means 80%. HCM. What is CM? Cache memory. H stands for hit rate. 0.8. Has an average latency of 10 nanosecond. TCM, cache memory access time 10 nanosecond. At the same time, miss penalty 100 nanosecond. While performing reading operation, first CPU tries to read the word from cache memory. If it has occurred, main memory does not involve in this operation. Main memory involves in this operation when there is a miss in cache memory. The amount of time needed to access a word from main memory is nothing but miss penalty. How much time it is? 100 nanoseconds. Simply it is nothing but TMM. When miss has occurred in cache memory, then only miss penalty is considered. Nothing but main memory access time, nothing but 100 nanosecond. First of all, to solve this question, compute the average memory access time for this. AMAT, average memory access time for this. In this expression for a two-level system, average memory access time is nothing but HCM into TCM plus 1 minus HCM into TMM. What is TMM? Main memory access time. In this, here HCM is nothing but 0.8, the TCM is nothing but 10 nanosecond, plus 1 minus HCM is nothing but 0.2 into TMM is nothing but 100 nanoseconds. Finally, it is nothing but 0.8 into 10, 8, 0.2 into 100, 20 means 28 nanosecond. It is the old cache average memory access time. In this, after optimization, what about the rules he gave? TCM has been increased. TCM has been increased. Look here. After optimization, TCM has been increased from 10 to 15 nanosecond at the same time. What he asked in the question? He asked the minimum hit rate means HCM. Next, at the same time, one more point he mentioned clearly. After optimization such that it should not increase the average memory access time, means for new system. What about AMAT? Average memory access time is less than or equal to 28 only. Generally, we take 28 here because it is the maximum value. Because what he mentioned here, it should not increase the average memory access time. So 28 is the maximum average memory access time. 28 nanoseconds is the maximum average memory access time for new version after optimization. Next, you should find HCM at the same time. What about TMM? There is no change, 100 nanosecond, because he mentioned the same thing clearly. Whereas the miss penalty is not affected, means TMM is not affected. Then what about average memory access time? Maximum here 28. Expression is same expression, HCM into TCM 15 nanosecond plus 1 minus HCM into TMM 100 nanosecond. Its maximum value is equal to 28. That's why you should take 28 here. Now in this, it is nothing but 15 into HCM plus here 1 minus HCM into 100 means 100. 100 HCM means minus 85 HCM is equal to 28 minus 100 means minus 72. Minus minus get cancelled. So what about HCM here? HCM is nothing but 72 by 85. What he asked here? He asked to round the answer for 2 decimal places. So its value is, we are getting value 0.847 something. So nothing but 0.85, because he asked to round off the answer for 2 decimal places. So what about answer here? 0.85. Watch this question. A processor X1 operating at 2 GHz has a standard 5-stage RISC instruction pipeline having a base CPI clocks per instruction of 1 without any pipeline hazard. If there is no pipeline hazard, only 1 clock cycle is sufficient for executing an instruction in 5-stage pipeline. What about frequency? 2 GHz. What about time cycle value? 1 by 2 GHz means 1 by frequency provides the time cycle value. Next, for a given program P, program name is P, that has 30% branch instructions, control hazards incur 2 cycle stalls for every branch. For each branch instruction, 2 clock cycles are required. Nothing but penalty, branch penalty. A new version of the processor X2, first one is X1, second one is X2, operating at the same clock frequency, has an additional branch predictor circuit. Predictor unit means predictor circuit, branch predictor unit, BPU, that completely eliminates stalls for correctly predicted branches. When branch is correctly predicted, no stall is required. There is neither any saving nor any additional stalls for wrong predictions. Additional stalls are required for the instructions, branch instructions, which are not correctly predicted. There are no structural hazards and data hazards for X1 and X2. There is no structural hazard, means resource conflict. Data dependency hazard also not there. If the BPU, branch prediction unit, has a prediction accuracy of 80%, BPU provides accuracy for only 80% but not for 100%. The speed up rounded off to the 2 decimal places obtained by X2 over X1 in executing P is dash. What is P? P is nothing but a program. First, get 100% clarity in the question. Better to read the question 3 or 4 times, then only we will get the clarity in the question, given question. Observe this. Here X1, it is the first CPU, pipeline CPU. What is K here? K means number of stages, 5. For solving this question, number of stages are not needed to consider. Next, what about clock frequency? Given is nothing but 2 GHz. Then clock cycle time is nothing but 1 by frequency provides clock cycle time 0.5 nanosecond. It is nothing but, in our style, nothing but segment delay time. When segment delay time is not given, 1 clock cycle is considered as 1 segment delay time. T segment. Segment is nothing but suffix. How many branch instructions are there? 30%. How many number of instructions? P. Now in this, first of all, for X1, what about average instruction time? Average instruction time. Is nothing but number of branch instructions is equal to 30%, means remaining 70% are non-branch instructions. For non-branch instruction, don't consider a hazard because he mentioned the same thing clearly. That's why, while finding average access time, average instruction time in this, 0.7 is nothing but the number of non-branch instructions. For these 0.7, 1 clock cycle is compulsory required. For executing any instruction, 1 clock cycle is compulsory required. At the same time, no stalls. 0 means no stalls. S means no stalls. Plus 30% are branch instructions. For each branch instruction, one clock cycle is compulsory needed for execution. Along with that clock cycle, 2 more clock cycles are needed as stalls in this into T segment. Here T segment is nothing but 0.5 nanosecond. Now x1 time is nothing but 0.7 into 1, 0.7 plus 0.3 into 3 means 0.9 into what about T segment 0.5 nanosecond is nothing but 0.7 plus 0.9, 1.6. 1.6 into 0.5 means 0.8 nanosecond. Watch carefully. Here x1 is nothing but 0.8 nanosecond. It is nothing but average instruction time. It is nothing but average instruction time. Next, what about x2 here? For x2, in this BPU unit is used to provide the branch prediction. Out of 100 instructions, it provides accuracy for only 80%. What about remaining 20%? There is no accuracy, means for 80% branch instructions, there is no additional stall, but for 20% branch instructions, 2 more stall cycles are needed for each. Now in this, for x2, same here. The point what we have mentioned there and here are same. 0.7 into here, 0.7 into 1 plus 0. Here these are non-branch instructions. These are non-branch instructions plus 30% branch instructions are there. In these 30%, 0.3, 30%, 1 plus 0, no stalls are required. For how many instructions? 80% means 0.8 plus stalls are required for only 20%, means in these 30%, 2 more stalls are required for only 20%. What about computation here? 0.18 into T segment means 0.5 nanosecond. Then it is nothing but into 0.5 nanosecond. Finally, answer is 0.56 nanosecond. Finally, answer is, watch this one once. Watch this one once. 0.7 branch instructions are there. In these, for 80% branch instructions, no stall is required because branch prediction unit provides the target address without having any stall. Next, for remaining 20%, branch prediction unit does not function, means 2 more additional stalls are required for each branch. That's why these are nothing but additional stalls. So for 20%, so from this 0.7 into 1 plus 0 means 0.7 plus 0.3 into 1, 0.3 into 0.88 means 0.24 into 0.3 into 3 means 0.9 into 0.2, 0.18. Finally, entire thing will be multiplied with T segment. T segment is nothing but 0.5 nanosecond. That's why we got 0.7 plus 0.24 plus 0.18, nothing into 0.05, nothing but 0.56 nanosecond. He asked the speed up. While computing speed up, always numerator is represented with longest delay and denominator is represented with shortest delay. Here, what about longest delay here? 0.8 nanosecond by 0.56 nanosecond. So finally, correct answer is 1.4285, like that. He asked to round off this one to 2 decimal places. That's why 1.43. So what about final answer? 1.43. Watch this question. Consider a system with a 2 KB direct mapped data cache with a block size of 64 bytes. First, get 100% clarity in the question. Try to understand question clearly, and at the same time, better to read the question minimum 3 times. The system has a physical address space of 64 KB and word length of 16 bits. During the execution of a program, 4 data words PQRS, these are data words but not data blocks, are accessed in that order 10 times. First processor accesses P, next Q, next R, next S. It accesses 10 times in this order, means PQRS like that. Means total number of words to be accessed is 40. PQRS 10 times means 4 into 10, 40. Hence there are 40 accesses to data cache altogether. Assume that the data cache is initially empty. Assume that the data cache is initially empty and no other data works. No other data words are accessed by the program. No other data words are accessed by the program. The addresses of the first byte of PQRS are, it is the P address, Q address, R address and S address. First byte, word size is 16 bit respectively. For the execution of the above program, which of the following statements is /R true with respect to the data cache? Question is like this and options are like this. It is MSQ question. It is MSQ question, multiple select question. Options are like this. A, every access to S is a hit. B, once P is brought to the cache, it is never evicted. C, at the end of the execution, only R and S reside in the cache. D, every access to R evicts Q from the cache. Here, he asked, for the execution of the above program, which of the following statements is /R true? He asked the true statements. Which of the following statements true with respect to the data cache? I think you are clear in question. Okay, now. Type of mapping is direct map. At the same time, block size 64 bytes. Block size 64 bytes. Size of the block is same in main memory and cache memory. Nothing but 64 bytes means 2 power 6 bytes. Here, he mentioned the byte addresses and word addresses at the same time. He mentioned the word addresses at the same time. He provided the cache memory and main memory in bytes. That's why better to take the physical address format in bytes. If we take physical address format in word, then also there is no problem. Here, cache memory size, CM size, cache memory size 2 KB means 2 power 11 bytes. Main memory size 64 KB. Physical memory is nothing but main memory means 2 power 16 byte. That's why PA. What is PA? Physical address size 16 bit. Next CA. cache address size means to address one of the words in cache memory, how many bits are required? 11. Then since it is direct mapped cache, tag size is nothing but PA minus CA, nothing but 5 bits. At the same time, how many cache lines are there? CL, number of cache lines. One cache block is also known as one cache line. Number of cache lines is nothing but cache memory size 2 power 11 bytes by block size nothing but 2 power 6 byte, nothing but 2 power 5 means 32 means CL02, CL31. CL means cache line. Starting number is 0, ending number is 31. Okay. Next, how many main memory blocks are there? MB, number of main memory blocks. Here, main memory capacity is 2 power 16 byte and each block size is 2 power 6 byte. 2 power 6 byte, then it is nothing but 2 power 10 means 1024 means MB02, MB 1023. Okay. Next, physical address format in direct mapped cache is like this. Physical address format in direct mapped cache is like this. Let it is physical address. Physical address means main memory address. Here, if we consider only byte address, nothing but 16-bit. If we consider word address 15-bit, here it is better to solve the question with byte address. Then we are discussing direct mapped cache. Left side is nothing but a tag. What about tag field size? Tag field size is nothing but 5-bit. It is nothing but cache line offset, CL offset, line offset. Offset means address. How many bits are required for this? Since cache memory is having 32 blocks, again 5-bit. How many bytes are available in each block? 2 power 6, that's why its size is 6-bit. So total size is 16-bit. It is nothing but word offset, means word address. Each block is having 64 words. Here, 5 bits are used to provide the cache line number. Those are nothing but CL0 to CL31. If all are zeros, 5 are zeros, it represents CL0 and 5 are ones, it represents CL31. Okay. Next, one more point, very, very, very important, be dedicated in this. Only this field is known as cache line field, cache block field. This entire field is known as, this entire field is considered as main memory block field, means MB field, main memory block field, except word offset. Remaining all bits are used to represent main memory block number. Only center one is used to represent cache memory block number. Okay, next. What about the addresses he gave? P, word address, Q, R, S. First, P is nothing but A248. What about P here? P is nothing but A248 base 16. P is nothing but A248. 0x represents hexadecimal. Next, in this, find the binary value for the same. A means 1010, 2 means 0010, 4 means 0100, 8 means 1000. Now in this, already I explained, least 6 bits are used for word offset. It is nothing but word offset. Here, next 5 bits are used for cache line offset. Next, these bits are used to represent main memory block number. In this, what about CL here? CL value is nothing but 1, 2, 4, 8 means it maps to CL9. This word maps to cache memory block number 9. What about main memory block number here? Main memory block number is nothing but 1010001001. Find the decimal value for the same. 1, 2, 4, 8, 16, 32, 64, 128, 256, 512. Means 512 plus 128, 640 plus 9, 649. Nothing but MB 649. Mean MB 649 maps to where? CL9. One more method is there for finding the mapping block number. It is nothing but K mod CL. What is K here? Main memory block number 649 mod. What is CL here? CL is nothing but number of cache lines, nothing but 32. Okay. In this, remainder is only 9. Means MB 649 maps to where? CL9. MB 649 maps to where? CL9. Means P maps to CL9 means cache line block number 9. What about Q here? We completed P. What about Q here? C28A. Q is nothing but C28A. C means 1100. 2 means 0010. 8 means 1000. A means 1010. Here, least 6 bits are used for word offset. Next 5 bits are used for cache block offset. Next, it is nothing but main memory block number. In this, 01010 means 1248, nothing but CL10. Means Q maps to where? CL10. P maps to where? CL9. P maps to CL9. Q maps to where? CL10. Here, one more method is also there. What about main memory block number here? MB value is nothing but 11000, 0101, 0, 1, 2, 4, 8, 16, 32, 64, 128, 256, 512. What about decimal value for the same? 512 plus 256, 668, 768 plus 10, 778. It is nothing but MB 778. Where it maps to CL10 or 778 mod 32 also provides CL10. Means its remainder provides 10. So finally, Q maps to where? CL10. P maps to CL9. Q maps to CL10. Okay. Next. What about R here? R is nothing but CA8A. R is nothing but CA8A. C 1100, A 1010, 8 1000, A 1010. Now, here least 6 bits word offset. Next 5 bits cache line offset. 01010 means nothing but CL10. Here these are nothing but main memory block number. What about main memory block number here? MB 1100101010 means 1, 2, 4, 8, 16, 32, 64, 128, 256, 512. 512 plus 256, 768 plus 32. 768 plus 32, 800. 810 means MB 810 maps to where? CL10 means R maps to, this address belongs to R maps to CL10. Okay, next. Next, what about S here? A262. S is nothing but A262. Here, A means 1010, 2 means 0010, 6 means 0110, 2 means 0010, 1, 2, 3, 4, 5, 6, nothing but word offset. Next, 5 bits are nothing but cache line offset, nothing but 1, 2, 4, 8, nothing but CL9, means S maps to CL9. Next, what about MB here? MB is nothing but main memory block number. MB means main memory block number. MB means main memory block number is nothing but 1010001001, 1, 2, 4, 8, 16, 32, 64, 128, 256, 512. 512 plus 128, 640, 649 means MB 649 maps to where? Again CL9. It represents S. Finally, remember this, P, Q, R, S. P maps to where? P maps to where? CL9. Q maps to CL10. P CL9, Q CL10. P CL9, Q CL10. Next, R maps to CL10. S maps to CL9. Initially, all cache blocks are empty. Order is PQRS. Order is PQRS. Okay? Watch carefully. Watch this. It is nothing but cache memory. In this cache memory, how many lines are there? 32. Those are nothing but CL02, CL0, CL1. Like that, it is nothing but CL9, nothing but CL10. Last one is nothing but CL31. These are cache lines. Now, mapping order is like this. First of all, processor accesses P, next Q, next R, next S. Initially, cache is empty. First of all, for first accesses of, means for accessing first 4 words first time, P, CL9. P maps to where? CL9 means, be dedicated in this. Here, first of all, P goes there. CL9. Next. Right now it is miss, compulsory miss. What about next one? Q, CL10. It is also compulsory miss. Next, R, CL10. Since it is direct mapped, Q is replaced with R because Q and R words map to same block. Next, S maps to CL9. S maps to CL9. Here P and S words are available. P and S words are available in the same main memory block. That main memory block number is nothing but 649. Means P is available in 649, main memory block number 649. At the same time, S is also available in the same. P and S main memory block number for these two is nothing but 600 and MB 649. Means these P and S words are available in the same main memory block 649, where it maps to CL9 only. Means P is nothing but S. Means P word and S words are mapped to where? CL9 only. If P is there, S is also there. Okay. Now, it is the first time. What about second time? Second time axis is like this. Again P. Means P maps to where? Same. Now, P for second time onwards it is hit. First time it is compulsory miss. Second time onwards it is hit. Next. What about next one? Q. Q maps to CL10. Q is not there. Here in CL10 R is there. So R is replaced with Q. Next. R also maps to same. Again Q is replaced with R. While accessing these words, first of all, R replaces Q. Later Q replaces R. Same thing will be repeated forever if order is same only. Next. What about next one? After this, S, where? CL9. Since P and S are in same block, since P and S words are in same main memory block, it is nothing but MB 649, not needed to replace or evict. Okay, it is the procedure. Whatever the number of times these words are accessed, it is the procedure. Finally, which words are available? P, R. If P is there, S also will be there because P and S are available in the same main memory block. Which word is not available? Q word is not available. Okay. After accessing 10 times, P is available. Where? In cache. At the same time. What about Q? Q is not available. Next. R and S are available. Already explained. If P is available, S is also available because P and S words are available in the same main memory block number. Means they map to same cache memory line number. So it is the situation after completion of the program execution. Means after accessing these four words for 10 times. Now go to question 1. For the execution of the above program, which of the following statements is/are true with respect to data cache? In this, observe options. Every access to S is a hit. Here, since P and S words are available in the same block, every access for S is hit because Here P and S are available in the same main memory block number. S, first one is true. P is nothing but S. P and S are same. Yes, it is true. What about second one? Once P is brought to the cache, it is never evicted. Once P is brought to the cache, it is never evicted. After mapping the P, not needed to evict this one because P and S are mapped to same. P and S words are available in the same main memory block number. That's why it is also true. Next, option C. At the end of the execution, only R and S reside in the cache. At the end of the execution, only R and S reside in the cache. After completion of execution, P is available, Q is available, R and S are, Q is not available, R and S are available, but in option what he mentioned, at the end of the execution, only R and S reside in the cache, only R and S. Not only R and S, P is also available. Okay, that's why it is false. Except Q, remaining all words are available. Next, every access to R evicts Q from the cache. Every access to R evicts Q from the cache. Every access to R evicts Q from the cache, yes. So it is also true. So correct statements are A, B, and D. Correct statements are A, B, and D because C is the false statement. What's the question? Let R1 and R2 be two 4-bit registers that store numbers in 2's complement form. For the operation R1 plus R2, which one of the following values of R1 and R2 gives an arithmetic overflow? It is related to overflow question, arithmetical overflow question. Here R1 and R2 contents are mentioned at the same time. These data are belonging to 2's complement notation. Simply data are represented in 2's complement notation. Now in this, what about the size of the data? 4-bit. Solution is like this. It is also MCQ question. MCQ question. Here, size of the data is 4-bit. In 2's complement notation, range is in signed to 2's complement notation. The range is, range for 4-bit, -8 to 2 plus 7, -8 to 2 plus 7 means when the operational result is between -8 and +7, overflow does not occur. Overflow occurs when the result is beyond this range only. When the result is beyond this range only. It is -8. It is +7. It is -8. It is the range provided by the same. Now what about option A? If we consider option A, come to option A once. R1 value. What about R1 value here? 1011. R2 value 1110. Find the decimal value for the same. Those are represented in signed 2's complement notation. Like that. What about B here, C here, D here? R1, R2, R1, R2, R1, R2. R1 value in B option 1100, R2 value 1010. In C option R1 value 0011, R2 value 0100. In D option R1 value 1001, R2 value 1111. Now find the decimal value for the same. While finding the decimal value for 2's complement form data, only MSB weight sign is negative, remaining all signs are positive. Means 1, 2, 4, minus 8, and 1, 2, 4, minus 8. Here, 1, 2, 4, minus 8, 1, 2, 4, minus 8. Same, only MSB weight is negative, remaining all weights are positive. If you observe option A, what about result? R1 content is nothing but, what about R1 value? R1 value is nothing but minus 5 plus, here it is nothing but minus 2. So result is minus 7. So it is in this range. So overflow does not occur. Next, what about option B? Here, this value is R1 value is minus 4. R2 value is minus 6. Means minus 4 plus minus 6, minus 10. R1 plus R2 minus 10. Yes. Yes. It gives arithmetical overflow because it is not in this range. The smallest negative data that can be stored by the 4-bit register is nothing but minus 8. But here, result is minus 10. So option B is correct. Check why C and D are wrong. C, R1 content is here plus 3. R2 content is plus 4. Result is nothing but plus 7. So it is in this range. So it is also false. What about D option? R1 content is nothing but minus 7 plus R2 content minus 1, nothing but minus 8. So it is also in this range. So it is also false. So what about correct option B? Watch this question. One more question from COA subject. Excellent question it is. And it is MSQ question. MSQ, multiple select question. First, get 100% clarity in the question. Let WB and WT be two set associative cache organizations. There are two set associative cache organizations that use LRU algorithm, LRU block replacement algorithm for cache block replacement. WB is a write back, WB write back cache, and WT is a write through cache. Which of the following statements is /R false? Since it is MSQ question, correct options can be 1 or 2 or 3 or 4. Okay. First of all, before going to read the options, first you come to know what is write through and what is write back. Watch the diagram carefully. Now, CPU, it is cache memory and it is main memory. Here also, CPU, cache memory, and main memory. This diagram is used to represent write through cache where this diagram is used to represent write back cache here. Write through means WT according to the given question style. Write back means WB. In this, first of all, come to know the nature of operation of write through and write back in this. These are nothing but the data lines. Data is transferred between one level memory to another level memory or from processor to memory with the help of data bus only. Group of data lanes is nothing but the data bus. In this, in write through, which type of strategy it uses, which type of phenomena it uses. In write through, when there is a missing cache memory, what happens? Main memory involves in the operation. Then processor reads the respective block from main memory. It is during reading operation. During writing operation, what happens? CPU writes the information. CPU writes the information not only in cache memory but also in main memory. Means both cache memory and main memory are simultaneously updated. Means main memory is filled with recently executed information. Then what about the merit of this? Recently executed programs are available to the I/O devices. Between I/O devices and main memory, DMA controller is there. What about the merit of this one? In this, main memory is having the files which are having same files in cache memory. Means main memory and cache memory are having same files. When miss has occurred in cache memory during reading, no problem. The duplicate file is available in main memory. First of all, you come to know the demerit in the write through cache. In this, valuable memory space is wasted because for storing only same information, we are using a block of information here and here, means valuable memory space is wasted. But what is merit? Extra bits are not needed to maintain for write through cache, like dirty bit like that. It is the merit. Come to write back cache in this. While performing writing operation, first of all, CPU updates that information only in cache memory but not in main memory. Whenever eviction is needed from cache memory, then only the respective block is transferred from cache memory to main memory. To protect that block, extra bit is needed. It is nothing but the dirty bit. The dirty bit concept is not needed in write through. It is needed only in write back. At the same time, what about the merit of this? Since a block is stored only in one level memory, first of all, only in cache memory, when eviction of that block is needed from cache, then only it will be sent to the main memory. Means no valuable memory space is wasted. But what about demerit? Some extra bits are required, like dirty bit. Okay, advanced systems are utilizing only this phenomena. Come to question. Which of the following statements is/are false? A. Each cache block in write B and write WB means each cache block in WB and WT has a dirty bit. It is false because dirty bit is required only for write back but not for write through. Next. Every write hit in WB leads to a data transfer from cache to main memory. Watch the statement once again. Every write hit means while performing the write operation in certain level memory, if that block is already available, if that word is available, then it is nothing but a hit. When a hit has occurred, eviction is not required. What he mentioned in this, Every write hit in WB leads to data transfer from cache to main memory. It is false. When write hit has occurred, not needed to transfer data from cache to main memory. When miss has occurred, then only it is needed to transfer the information from cache memory to main memory. Information means block of information means block of words. Next. C. Eviction of a block from WT will not lead to data transfer from cache to main memory. Here, eviction of a block from write through. Eviction of a block from write through will not lead to data transfer from cache to main memory. Yes, because in write through, same information is available. Same block of words are available in both cache memory and main memory. While evicting a block from cache memory, not needed to transfer that one to main memory because already it is available. Already we discussed the nature of write through and write back. So it is true. D. A read miss in WB never lead to eviction of a dirty block from WB. Yes, it is also false. Watch the statement once. A read miss in write back will never lead to eviction of a dirty block from WB. When read miss has occurred, compulsory dirty block is needed. The dirty block is needed. That's why it is also false. A read miss in WB will never lead to eviction of a dirty block from WB. Why it is false? A read miss in WB write back will lead to eviction of a dirty block. Will lead to eviction of a dirty block because miss has occurred. Then eviction is compulsory required. From where? From cache memory to where? To main memory. That's why it is also false. What he asked in the question, which of the following statements is/or are false? Correct. False statements are A, B, and D. A, B, and D. So correct options are A, B, and D only.